Hi everyone, welcome to Rodha. My name is Apurv and I'm a quant and LRDI faculty at Rodha. Today we are here to discuss few questions of CAT 23 slot 3. They are algebra questions, right? And I would say it was a nightmare for a lot of you, right? The feedback that I have received from people is that CAT 23 was a nightmare in terms of quant, right? But let's see how simple the questions were. It's just that concepts have to be in place, right? That is something that I keep telling all my students also at Rodha, that the guys, if your concepts are in place, then CAT questions is a cakewalk. You just have to be very solid with the basics, right? The basics have to be placed. Whether it's a 2-layer, 3-layer, 4-layer question, doesn't matter. You just have to break the question and solve it part by part, right? Okay, before we move ahead with this video here, so we have this complete booster course for CAT 24 which we launched on September 5th, right? And Ravi sir has already started taking classes in this particular booster here. So we have had couple of classes in both quant and LRDI as well as verbal, I think, right? So I would want you guys to have a look at these booster courses, because towards the CAT 60-70 days to CAT, you really need that kind of a push towards the end, right? I know most of you are writing mocks and might be demotivated by low scores, but this is a time when you have to push that extra mile and go full throttle on whatever little gasoline you have. So I think this booster is gonna be of great support to you guys. Yes, right? Booster course is something where we'll be doing a lot of questions, a lot of quantitative aptitude questions. That is, we have already written here 1500 plus quant questions, right? A lot of LRDI sets is something that you'll be doing. 30 different sections is what you have, right? New and challenging questions. Definitely, that is a pedagogy of Rodha, that we always come up with new and challenging questions, right? So I would suggest that please go ahead, have a consider this for your CAT preparation. If you think that you need that extra support towards the end and you want to get a 99 plus percentile, I think this can be a great add-on in your list of whatever you have done in your preparation till now. This can really boost your score. That is why the name is booster, right? Alright, so let's get started with the video here. So the first question is a logarithmic question. It's a question from log. Let's have a look at this question. It says, for a real number x, if 1/2 comma log to the power x minus 9 to the base 3 upon log 4 to the base 3 and this term are in AP, then the common differences. Alright, now seems like a very difficult question, isn't it? It's very scary at the face of it, right? But let's try to understand a bit of it. Okay, so one thing that the first thing that I would observe here is, if you see here, there's a 3 here, right? And there's a 3 here, right, in the base, right? This is 5 and this is 5, right? So the moment I see this 3 and 5 now, the first thing that should strike to my mind, जो सबसे पहली चीज मेरे दिमाग में क्या आएगी, is the base change formula. So we know that log of a to the base b is equal to 1 upon log of b to the base a, which is also same as if I introduce a new base, that is log of a to the base c upon log of b to the base c. So this is your base change formula, right? So can I say my expression is something in this form, right? And if I combine these two by using the base change formula and this as well, you can observe there's a 4 here and there's a 4 here. So both of these numbers will come in the base of 4. So that is the very first step that I'm gonna do, right? So I'm gonna write this expression as, I'll probably write it as log of 2 to the power x minus 9 to the base 4, ठीक है? और इसको हम लिख लेंगे log of 2 to the power x plus 17/2 to the base 4, right? Now why would I want to leave this 1/2 alone like this, है ना? इसको ऐसे क्यों छोड़ना है? He might feel sad about why am I not in the log form. So let's bring this 1/2 also in the log form, ठीक है? इसको भी log के form में लाते हैं. So we know a formula that log of a to the base of a is 1, right? Log of a number to the same base is 1. So can I write 1/2 as nothing but log of 4 to the base 4 raised to power 1/2, right? So this is definitely 1/2, because if I bring 1/2 to the forward, right? If I bring 1/2 to the forward, then this will become log of 4 to the base 4, right? And this is nothing but 1. So 1/2 into 1 is 1/2. So it can be written in this particular form, right? Now if it can be written in this particular form here, so what I can do here is, I can write this 4 as 2 to the power 2, right? I can write it as log of base 4 2 to the power 2 and this is raised to power 1 by 2, right? Now we all know that a to the power m raised to power n is always equal to a to the power m into n, right? So 2 and 2 will get cancelled, so basically I'm getting this 1 by 2 as nothing but log of 2 to the base 4. So 1 by 2 is basically log of 2 to the base 4, right? So these are my 3 terms, okay? Now, so this is what I have, log of 2 to the base 4 here. Now these 3 terms are in AP, right? And I know that if 3 terms are in AP, right? For example, if I know for a fact, let me take a fresh page here, okay? So I know for a fact that if 3 terms are in AP, let's say A, B, C are in AP, right? So the terms, the difference between the two considered terms is, that is D, denoted by the common difference letter D is always same. So we know for a fact that B minus A is equal to C minus B, right? But I really don't want to do this on this log thing, right? I just don't want to get involved. I don't want to write a huge function here that log of 2x 2 to the power x minus 9 minus log 2 and then is equal to, I just don't want to do that much of mathematics here. So what I'll do here is, I would probably, let's say I'll say log of A to log and then log B and let's say log C, alright? So I would try to simplify my question here. So let's say these are in AP. So if this is in AP, right? So can I say common difference, that is B minus A, second term minus first term, that is log B minus log A, should be equal to, can I say log C minus log B, right? Should be equal to log C minus log B, that is this minus this, right? Now log M minus log N is same as saying log of M by N, right? So this can be written as log of B by A and this can be written as log of C by B. Now if I get rid of the log, so basically I'm getting B by A is equal to C by B. So that means what? B square is equal to A into C. Oh, nice. So this is a nice derivation that I've got here. So you guys need to remember, if log A, log B and log C are in AP, that clearly implies that A, B and C should be in GP, right? A, B and C are always in geometric progression. So that is something that you need to remember as a result, right? Because B square is equal to A by C. B square is equal to A by C. Why? Because when they're in GP. So I would say the second term upon the first term, that is B upon A, should be equal to the third term upon the second term, right? If the 3 terms are in GP. So C by B. And this brings me to nothing but I can say B square is equal to A into C. So I have got a relation here that if log A, log B, log C are in AP, then B, A, B, C are in definitely in GP. Okay. So can I say now that these 3 terms, this and this entire thing, right? These 3 terms are gonna be in GP here, right? So if these 3 terms are gonna in GP, so I can say 2 to the power x minus 9, that is B square, whole square, right? That is B square is equal to A into C, that is 2 into 2 to the power x plus 17 by 2, right? Never make your question complicated. Never ever in CAT you should try to do complex things. You should try to avoid writing complex things on the screen on your paper, so that your mind stays calm. The moment you see a lot of powers and log, our mind tends to get blank. We just don't know how to solve, right? So like I see a 2 to the power x, I just don't want to deal with 2 to the power x. Let's say I would probably write 2 to the power x as, let's say, k. Okay, if I take 2 to the power x as k, so my equation becomes so simple, right? It has become so simple. K minus 9 whole square equals 2k. I'm gonna multiply this 2 inside the bracket, so 2 into 17 by 2 is gonna give me a 17 here, right? Now this is so easy for me to solve. It's a simple quadratic equation and I can easily solve this. Anybody who is preparing for CAT can easily solve it. So just observe a terrific question, right? A terrifying question, not a terrific one, probably a terrific one too. Okay, so a terrifying question like this, right? Just look at this. Such a difficult question, a question that looks so difficult at the face of it seems so easy now, right? So this is a simple equation which anybody can solve, right? So just have a look here. This particular terms here, which was so horrifying at the face of it, has simply boiled down to this quadratic here, right? It is such a simple question which is boiled down to quadratic. So let's try to simplify this quadratic here. So k minus 9 whole square is nothing but k square plus 81 minus 18k, राइट, यही होता है ना, a माइनस बी होल स्क्वायर, a स्क्वायर प्लस बी स्क्वायर माइनस 2ab, राइट, इक्वल्स 2k प्लस 17, राइट. सो यहाँ से k स्क्वायर, आई विल गेट माई क्वाड्रेटिक एज k स्क्वायर minus 20k, right, and plus 64 equals to 0. So I want to factorize this and I want to break it in the form of 64 such that it turns out to be nothing but I can say 20, right. I want 64 in terms of 20. So that's pretty easy, right. I can write it as 16k and minus 4k, right. So on factorizing this, I'll get nothing but k minus 16 and k minus 4. So these are the two values of k that I'll be getting, which is 16 comma 4. Now again, if I'm getting two values as 16 comma 4, now you might be wondering that what value should I use, right? What should be the right value of k? Obviously there's no multiple answer here, there's only one common difference that the question is asking me, right? So if you observe here, if your k was 2 to the power x, right, my k was 2 to the power x, so if I take k as 4, right, if I'm putting k as 4, right, so if I put this 2 to the power x as 4, then this term here would become 4 minus 9 inside the bracket, right, and that will become minus 5, and log of a negative number is not defined, right. That clearly rules out my possibility of k is equal to 4, which is not possible. So definitely k is equal to 16. So if k is equal to 16, that means 2 to the power x is equal to 16, right. So we've got my value of 2 to the power x as 16. But the question is asking me the common difference. Alright, so we can have the common difference here now. So 2 to the power x is equal to 16 here. So these are my terms, right. So I'm just gonna take again a fresh page here. So my three terms were nothing but log of 2 to the base 4, and second term was log of 2 to the power x minus 9 to the base of 4 again, right. I don't need the third term, but still I'll write it. चलो लिख देता हूँ मैं, log of 2 to the power x plus 17 by 2 to the base 4. So common difference if I need, so I basically need the difference of this and this, right. Now can I say log of 2 to the power x minus 9 to the base 4, right, minus log of 2 to the base 4 is gonna be my common difference, right. That is the common difference for the AP. Now if this is a common difference, so 2 to the power x we have got as 16 here, right. This value has turned out to be 16, okay. So can I say log of 16 minus 9, that is log of 7 to the base 4 minus log of 2 to the base 4 is my common difference, and log m minus log n is equal to log of m by n. So that is the identity which you need to be aware of. So this will come out to be nothing but log of 7 upon 2 to the base 4, and that is your common difference. So the answer for this particular question is option number C, that is log of 7 by 2 to the base of 4. So that is my required answer, right. So again, it was not a very difficult question, it's just that you need to be very thorough with your concepts, right. Alright, let's move to the next one here now. It says for some real numbers a and b, the system of equations x plus y equals to 4, okay. So x plus y equals 4 and a plus 5 into x, alright. So a plus 5 into x plus b square minus 15 into y, okay. So b square minus 15 into y equals 8b, fine, has infinitely many solutions for x and y, okay. So has infinitely equals 8b has infinitely many solutions for x and y and the maximum possible value of a and b's, alright. So when do we have infinite solutions, right? Now can I say any equation of the form ax plus by equals to k represents a straight line, right? Represents a straight line, isn't it? Now if the two lines overlap each other, right, if I have another equation of ax plus by equal to k form, and if both the lines overlap each other, then I can say the equation has infinitely many solutions, right. So there's a condition that you need to be aware of, which is if I say that there are two equations, which is, let's say, a1x plus b1y equals c1 and a2x plus b2y equals c2, then for infinitely many solutions we have a1 by a2 equals b1 by b2, which is also equal to c1 by c2, right. So this is a condition for infinitely. So this is my condition for infinitely many solutions, right? And here in this question we have infinite many solutions as per the given set of the question here, right? It has infinitely many solutions. So let's apply this here. So a1 and a2 are nothing but the coefficient of x, and b1 and b2 are nothing but the coefficient of y, and c1 and c2 is my constant term, right? So can I say here that 1 upon a plus 5 should be equal to 1 upon b square minus 15, which is also equal to 4 upon 8b, right? So can I solve the second and third one to get my value of b, right? So from here what do I get? I can say I can cancel this 1 and 2, so I'll get nothing but 2b equals b square minus 15. So from here I can say b square minus 2b minus 15 is equal to 0. I can factorize it as 5 and 3, so minus 5b plus 3b minus 15 equals to 0. So from here I can say that the value of b on factorization of this will get nothing but I can say b minus 5 into b plus 3 is equal to 0. So this is the value of b I am getting from here. So the value of b is nothing but 5 comma minus 3. So I'm getting two set of values for b, right? Now let's pair up the first and the second one. Okay, so probably I'll take a new page here. So I can say 1 upon a plus 5 equals 1 upon b square minus 15, right? 1 upon b square minus 15. So I'll take case 1. When my b is equal to minus 3, right? So if b is minus 3, in that case I can say 1 upon a plus 5 is equal to 1 upon minus 3 square is 9, so this will be 9 minus 15, right? So this will cross multiply, so I'll get nothing but I can say 9 minus 15 is basically minus 6, so minus 6 is equal to a plus 5. So from here the value of a is equal to nothing but minus 11, right? A is minus 11 and b is minus 3, so we have to get the value of a into b. So a into b in this case will be nothing but 33, right? So that is the value of a into b. Let's take the second case here, which is case 2. Case 2 is when b is equal to 5, right? The other value, possible value of b was nothing but 5 here, right? So case 2 and b is 5. So if b is 5, then I'll get 1 upon a plus 5 is equal to 1 upon. Now 5 square here, if I substitute 5, I'll get 25 minus 15. So that brings me to nothing but 10 is equal to a plus 5. So the value of a is nothing but 5 from here. So if a is 5 and b is also 5, then the value of a into b is, I can say 25. But the question wants me the maximum possible value of a and b. And if you see here how the options are made in CAT, 25 is also there, 33 is also there. So the moment you make a silly mistake and you get the incorrect answer. So the maximum possible value is definitely 33. So the answer for this question is option number B, right? So again, a very easy one on a very simple concept of infinitely many solutions, right? Let's move to the next question here. It says a quadratic equation x square plus bx plus c is equal to 0 has two real roots. If the difference between the reciprocal of the roots is 1 by 3 and the sum of the reciprocal of the square of the roots is 5 by 9, then the largest possible value of b plus c is okay. Now, see, this question is on the face of it, it's a difficult one, right? But we can make this question easy. Let's understand how. Okay. So x square plus bx square plus c. Let's say the roots of this equation is alpha comma beta. Alright. So if I have roots as alpha comma beta here, and it says the reciprocal of the roots is 1 by 3, sum of the reciprocal of the roots is 5 by 9, right? So that is gonna make my life complicated, right? Suppose I'm writing 1 by alpha minus 1 by beta is equal to 1 by 3, and that's gonna give me everything in terms of fractions. So that would make my question very complicated here, isn't it? So I'll just try to make my life simple. So probably I'll say I'll have an equation whose roots are, let's say a quadratic in y. I'll try to get a quadratic in y, right, where the roots are nothing but 1 by alpha and 1 by beta, right? Just the reciprocal. I'll frame a quadratic which has the reciprocal roots. That is, if the roots of this are alpha beta, then I'll have a quadratic which has roots 1 by alpha and 1 by beta, right? Now if alpha beta are the roots of this quadratic here, right, so can I say x is equal to alpha comma beta? So I'll replace this alpha with x here. So y is equal to 1 by x. So if y is equal to 1 by x, that clearly implies x is equal to 1 by y, right? So this is basically a transformation of equation to get a new equation whose roots are 1 by alpha and 1 by beta. So once I've got the value of x as 1 by y, I substitute it in this particular quadratic. So I'll get nothing but 1 by y whole square plus b into 1 by y plus c equals to 0, right? So on simplifying this, I'll get nothing but 1 by y square plus b by y plus c is equal to 0. And if I multiply the entire thing by y square, right? If I multiply the entire equation by y square, I'll get nothing but cy square plus b plus 1 equals 0. So this is my new quadratic in y, which has the roots as 1 by alpha and 1 by beta, right? Now let me denote this 1 by alpha and 1 by beta with something else, right? Let's say the roots are this of this quadratic are p and q, okay? Let's say the roots are p and q, where p is 1 by alpha, okay? Where p is nothing but 1 by alpha and q is nothing but 1 by beta, okay? So we know that the reciprocal of the roots is 1 by 3, the difference between the reciprocal of the roots, right? So basically here, can I say, if the roots are p and q, so can I say p minus q is given to me as 1 by 3, right? For this particular equation here, right? This one. So if p minus q is 1 by 3, and we also have that the sum of the reciprocal of these squares is 5 by 9, right? So basically 1 by alpha square plus 1 by beta square was given to me as 5 by 9, and 1 by alpha square is nothing but p square, right? So p square plus q square is 5 by 9. So this is the information that we have here, right? Now let me just take a fresh page here. So we have this quadratic here, that is cy square plus by plus 1 equals 0, and the roots of this quadratic are p comma q, right? So the roots of this quadratic are p comma q, which is where p is 1 by alpha and q is 1 by beta. So I can say sum of the roots, that is p plus q, should be equal to nothing but minus p by c, right? As per the formula, sum of the roots, right? And p into q here should be nothing but 1 by c. So we know that p minus q, right? P minus q has been given to me as 1 by 3, okay? So if I square on both the sides here, I'll get nothing but p square plus q square minus 2pq is equal to 1 by 9, right? Now the value of pq is 1 by c, so this will become 2 by c here, right? And p square plus q square we had already found is nothing but 5 by 9, right? So p square plus q square is 5 by 9. I'll probably write it here as well. So p square plus q square is equal to 5 by 9, right? So this is 5 by 9. So if I substitute here 5 by 9 and here 1 by 9, so from here the value of 2 by c will come out to be nothing but 5 by 9 minus 1 by 9, that is 4 by 9, right? So from here this implies 1 by c is equal to 2 by 9, or I can say c will be equal to 9 by 2 from here. So that is the value of c that we have got, right? Now we have this another equation here, that is p square plus q square is equal to 5 by 9. So we know for a fact that a square plus b square is same as a plus b whole square minus 2ab, right? So I can rewrite this as so p square plus q square, that is basically 5 by 9, is same as p plus q whole square minus 2 into p into q is how much? P into q is 1 by c, right? And 1 by c is basically, I can say 2 by 9, right? So 2 into 2 by 9, isn't it? So from here I'll say 9 by 9, right? Because 5 by 9 plus 4 by 9, this 4 by 9 will go on the other side, get added. 9 by 9 is equal to p plus q is minus b by c. So minus b by c whole square is nothing but b square by c square, isn't it? So from here I'll get nothing but b square is equal to c square. So that means b is equal to plus minus c, and the value of c is 9 by 2, so b will be plus minus 9 by 2, right? Now what is the question asking me? The question is asking me the maximum possible value of b plus c, right? So if I want the maximum possible value of b plus c, if I want this value to be maximum, in that case I need to take both b and c as maximum. So the maximum value of b is 9 by 2 and c is also 9 by 2, right? So the answer is definitely 9. So the answer for this question should be 9. Alright, so again not a difficult one, it's just that if transformation of equation does strike to your mind, then you'll be easily able to crack this particular question, right? It's difficult in exam scenario, obviously, yes, but then if you have practiced a lot of question of this particular type, which we are trying to ensure that every single type of question is practiced a lot of many times in booster course. That is why in the beginning of this session, I was suggesting you guys to take up the booster course, because yes, we are focusing on immense practice. That is the only key to crack CAT and get through all the quant questions. I mean, so 10 questions somebody is scoring 99% plus percentile out of 22, not even 50% of the questions, right? So that means people are less prepared, and that is what our purpose is, to make people more prepared, so that if the paper is on the difficult side, at least the people who have practiced well, they score really well there, and we don't get 99 percentile at 8 and 7 questions, right? So yes, I mean, we are on getting this achieve here, that Alright, let's move to the next question here now. So if x is a positive real number such that x to the power 8 plus 1 by x to the power 8 is equal to 47, then find the value of x to the power 9 plus 1 by x to the power 9. Alright, so before I get into this question, let's understand few things here, few very basics. So if I say x plus 1 by x is equal to a, so can I say x square plus 1 by x square plus 2 into x plus 1 by x into 1 by x is equal to a square? That is, I've scored on both the sides. So from here I'll get nothing but x square plus 1 by x square. This x and x will get cancelled. I'll be getting equals to a square minus 2, right? So if x plus 1 by x is a, then x square plus 1 by x square is a square minus 2, right? Let us assume that this value is b here, okay? So if this value is b, so can I say x to the power 4 plus 1 by x to the power 4 will be nothing but b square minus 2, right? So if b square minus 2, let's say this value is c in case, right? Let's just assume this value c. So in that case, can I say x to the power 8 plus 1 by x to the power 8 will be equal to c square minus 2? So using the same logic, that is, I'm squaring at every single step and I'm taking this plus 2 on the other side, I'm getting these particular values here, right? Now, in this particular question here, we have x to the power 8 as 1 by x to the power 8 as 47. Now here I've got x to the power 8 as 1 plus 1 by x to the power 8 as c square minus 2. So let us say that the value of this value here, c square minus 2, has been given to me as 47, right? So can I say c square will be equal to 49, right? And if c square is 49, then c has to be 7. Now what was c? C was x to the power 8 plus 1 by x to the power 8, and because as per the question x is a positive real number, that means I cannot take the negative value, so c has to be 7, right? Now if c is 7, so we noticed here that b square minus 2 is c, okay? So I'll say here b square minus 2 is equal to 7. So from here the value of b square is equal to 9, so that implies the value of b should be equal to 3, right? So the value of b is 3 here, right? Now if b is 3 here, so that is x square plus 1 by x square, right? Which is b. So in that case, can I say b was nothing but a square minus 2, right? So b was a square minus 2. So I can say a square minus 2 is equal to 3. So a square is equal to 5. That implies a is equal to root of 5. So that is the value of a. And a was nothing but x plus 1 by x, right? So from this one on, because of bad tracking, I have reached to the value here, that is x plus 1 by x is equal to a, right? Now let's understand something else here. That is, if x plus 1 by x is equal to a, right? So if I take a cube on both the sides, I'll get nothing but a cube plus b cube, that is 1 by x cube, plus 3ab, that is 3 into x into 1 by x, and in bracket I'll get a plus b, that is x plus 1 by x, and this is equal to a cube, right? Now if this is equal to a cube, so this x and x is cancelled, and can I replace this x plus 1 by x with a, right? So this can be a. So this, I'll get this as nothing but I can say x cube plus 1 by x cube, right? And 3 into a is going to be 3a, and if it goes on the other side, it will become a cube minus 3a, right? So that is the relation that I've got here. That is, if x plus 1 by x is a, then x cube plus 1 by x cube is going to be a cube minus 3a, right? Now if x plus 1 by x is a, and here the value of a is nothing but root 5, so can I say x cube plus 1 by x cube is going to be a cube minus 3a, that is root 5 whole cube minus 3 into root 5, right? That is going to give me nothing but I can say 5 root 5 minus 3 root 5, right? Which is same as saying 2 root 5. So that is the value of x cube plus 1 by x cube. Now if I again take a cube on both the sides, then I'll get x to the power 9 plus 1 by x to the power 9, right? And this will become nothing but again a cube. Now this value is 2 root 5, so I'll take a cube of this. So 2 root 5 whole cube minus 3 into 2 root 5, right? So this value will come out to be nothing but, I can say 2 cube is 8 and 5 root 5 is cube is 5 root 5. So that makes it 40 root 5 minus 6 root 5. So this will come out to be nothing but, I can say 34 root 5, and that will be my required answer. So the answer for this question is option number D. So the point here is that if I would have tried to write everything in terms of x to the power 4, x to the power 9, my page would have looked very cumbersome, it would have looked like very scary and stuff, because a lot of powers and stuff, right? But the moment I get this shortcut here, the moment I figure out a pattern here, which is in terms of square, it is following a pattern of a square minus 2, and in cube it is going to follow a pattern of a cube minus 3a, then I can easily crack my question. I just have to backtrack, get to this value, and then just take a cube minus 3a, and I'll get to my required answer, that is 34 root 5, right? So the point is, again, it boils down to the thing that if you know these things, then it becomes easy for you in CAT. If you do not know these things, then you have to put in your brains in CAT, which would ideally take you extra plus 2 minutes. But that does not imply that these questions are not doable. They're definitely doable questions. It's just that how well you have practiced and how many different varieties you have covered, right? So on that note is what I suggest, that we at Booster course that we have launched on 5th September, our major motive behind it is that we make sure that you practice immense number of questions, right? We ensure that there are a lot of sets that you do, there are a lot of questions that you practice, so that you are very well prepared for CAT. No matter what is thrown at you during the D-Day, on the D-Day, you are very well equipped and ready to tackle it, right? So I think we'll end this video here, and we'll meet in the next video. So in the next video also I'll be coming up with algebra questions of CAT 2023. First I'll cover all the questions of slot 3, and then I'll move to slot 2, and then to slot 1. Alright, thank you everyone.